Hi, my name is Joe Wendy. Here I'll be presenting our research on advancing fragmentation strategies development in LC-MS metabolomics. The research was done by our team from the University of Glasgow and also from Wageningen University. Tandem mass spectrometry is increasingly used in untargeted metabolomics to identify unknown molecules. The spectra for the fragmented molecules can be matched to databases such as mass bank and GMPS to deduce the possible annotations of the fragmented ions. The success of matching and identification often depends on the quality of fragmentation data. The more MS features for which high-quality spectra are acquired, the more molecules could be identified. The number and quality of spectra acquired is influenced by the choice of fragmentation strategy. A good MS2 acquisition strategy should produce spectra of a high quality for as many of the ions present in the sample as possible. Better strategies lead to higher quality data. It also increases the annotation rates in untargeted metabolomics. Common strategies, including the conventional Top-N data-dependent acquisition, also known as DDA, could potentially be suboptimal. It fragments large peaks many times and wastes valuable MS2 scans fragmenting noise. To address this shortcoming, we present a new novel fragmentation strategy called SmartROI, in which fragment spectra acquisition is informed by regions of interest, also known as ROIs. These ROIs are constructed in real time from MS1 scans. SmartROI is based on a traditional Top-N DDA duty cycle, but with additional rules to prevent unnecessary repeated fragmentation of a chromatographic peak. It tracks the intensity of the ROI and allows fragmentation events to occur only under particular conditions. ROIs from MS1 scans are constructed following the scent wave algorithm in XCMS. ROIs detection is the first step of all popular peak picking algorithms. And a mass peak not appearing in an ROI will never be picked and will not be included in any subsequent analysis. Keeping track of ROIs allows us to limit fragmentation to only mass peaks within them. This means we can intelligently refragment an ROI if it has changed significantly, allowing for much richer control than the standard Top-N approach. In SmartROI, a region is a candidate for refragmentation if its intensity increases by alpha percent or decreases by beta percent from when it was last fragmented. Alpha ensures that we obtain spectra of a high quality, and beta enables us to fragment multiple peaks within the same region. To develop SmartROI, we propose a general framework for developing, optimizing, and testing new strategies. Virtual Metabolomics Mass Spectrometer, ViMMS, is an LC-MS simulator built in Python that allows for scan-level control of the MS2 acquisition process. SmartROI was implemented as a controller class within ViMMS. Controllers in ViMMS can be optimized and tested in their simulations to determine if they give improved results without using an actual instrument. This saves many hours of expensive machine time. As part of this work, we enhanced ViMMS by adding a translational layer to allow controllers to run on Thermo Fusion instruments directly. This means controllers can be easily tested on the simulator and validated on the actual mass spec with minimal changes to their codes. We optimized SmartROI in simulation and compared it to a standard Top-N strategy. Two complex samples of serum, QCA, and beer, QCB, were used to seed the simulations. Performance was evaluated using coverage, the number of peaks that include one or more fragmentation events. From simulation, an alpha value of 1000%, which determines how much peak intensity has to increase to allow refragmentation, and a beta value of 0.1%, which determines how much intensity has dropped for refragmentation, were chosen. These were used for validation on the actual instrument. For real machine validation, peak picking was done using MZMine2. Coverage was then calculated for the following two conditions: picked, based on the pick picks for each method, and aligned, based on the pick picks which are common for both methods when aligned. The results here show that SmartROI improves upon the conventional Top-N DDA controller. SmartROI produces approximately 20% improvement in coverage, which means substantially more pick picks can be fragmented in SmartROI versus Top-N. It is also more efficient. SmartROI improves coverage while using fewer MS2 scans, and therefore producing more MS1 scans. This results in higher quality chromatographic peaks for intensity quantitation. In summary, we have introduced a novel fragmentation strategy, SmartROI, that detects regions of interest in real time and triggers fragmentation events only for ROIs. The strategy was developed on top of the ViMMS framework. The results show substantial improvements over Top-N. Thank you for listening. If you are interested to check out and contribute to our project, please visit the project page at https://github.com/sdrogers/ViMMS.